So, here, I'll just kind of slop it down up here someplace. What we did was, we sketched a set of coordinate axes. We sketched a point that we thought was 3, -2, so it's 1, 2, 3 units out here, 1, 2 units down, and then a slope of approximately 2, okay? And that's all we did here. Now, we observed that that line intersects the x-axis at some point, and we might have to extend the y-axis a little bit. It intersects the y-axis at some point. This point is the x-intercept. This point is the y-intercept. And of course, the graph keeps on going past both of these points. Well, here's the way I drew it. Now, I intentionally didn't attempt to get a slope of 2. I made the slope a little bit shallow. Okay, so my results are not going to be very good. And the graphs that most people drew, some people drew very accurate graphs. I didn't ask you to count, this many over and this many up, but some people did. And if you did, I think everybody that did that got accurate intercepts. But if you just did what I said, draw a line that looks like it has slope 2 through a point that looks like 3, -2, and then estimate your x and y intercepts, well, people got various results for the slope. On the average, they weren't a whole lot worse than mine. They're probably a little better. Okay? So, if you take my graph here and estimate the x-intercept, well, it's going to intercept here. If we continue the line, well, if this is the slope of the line, then the x-intercept would be here. And I estimated that to be about 4.3 on the x-axis. And of course, any point on the x-axis has y-coordinate 0. So this is the point 4.30. And then down here, well, I extended it on. I saw where the intercept is. Then I made my marks. I had 1 and 2. Then I did 3, 4, 5, 6. And by the time I got to 6, I passed the intercept. So I estimated the intercept to be 0, -5.9. That fits my graph. Now, the slope between any 2 points on this line, on the graph of this function, should be 2. So the slope between this point and this point will be 2 if I drew it accurately, but again, I didn't. And most people didn't. So how did I do? Well, the slope would be the rise divided by the run from this point to this point. The run is what? Well, the run is 4.3 minus 0, because the x-coordinate here is 4.3, the x-coordinate here is 0. And you can just look at the graph and see that if this point has x-coordinate 4.3, well, that is also the run. And the rise goes from -5.9 up to 0, so that's a rise of 5.9. So the slope is rise over run, which is 5.9 over 4.3, and I think that's about 1.4. Okay? Well, the slope should have been 2. It means I didn't make this graph steep enough. That's okay. I wasn't, again, trying to construct an accurate graph. I was just making an estimate, and the reason I asked everybody to do that was just so we could establish what an x-intercept is and what a y-intercept is. We should know that because it's been already done in the last couple of weeks for various functions, but want to establish it again in the context of this function and hope to lock in the concept. Okay, so again, we're looking for the points where the line goes through the x-axis and the y-axis. And then what's the slope between your 2 points and between my 2 points? Okay, that was a question that we answered. This is the slope between my 2 points. Some people got the right slope because they counted, but most people came out a little bit low in their slope, as I did. Okay, so anyhow, my estimated slope is 1.4, but the slope has to be 2. What's this mean? Well, it just means that either my graph is off or my estimates are off. And it's really that the graph is off, the line wasn't steep enough. Okay, now we ask, what are the coordinates of the x and y intercepts of this function? Okay, well, any point on the x-axis, y is 0. So if you take this equation and let y equals 0, you're going to have an equation that you can solve for the corresponding x-coordinate. And that point will be then on the x-axis, the point with y-coordinate 0 and x-coordinate whatever you get. And then for y-intercept, the point on the y-axis, the actual point on the y-axis is going to be obtained by letting x equal 0. So we have y equals 2x minus 8. We let x equal 0. We get the y-coordinate of this point on an accurate graph. So we proceed to do that. Do I have it here?
You see, that's the thing. He did, and he tried again.
Right. See, he knows the correct.
Okay. So we do it. Okay, y equals 2x minus 8. The x-intercept occurs when y equals 0. So we have 0 equals 2x minus 8. We solve for x. Well, we add 8 to both sides. We get 8 equals 2x. We divide both sides by 2. We get x equals 4. So that the x-intercept should be 4, 0. And the y-intercept occurs when x equals 0. So we plug in 0 for x. We get y equals 2 times 0 minus 8, which is negative 8. So the y-intercept is at x equals 0, y equals negative 8. These are the accurate intercepts. Now I draw a line through these points. Now notice that I tried to draw a line through the points, but I was a little low on this one, and I was a little low on this one. Okay, well, the point where x equals 3 should be negative 2, because remember the point 3, negative 2 was given as the point that we knew on this line. So this point should be 3, negative 2, but if we come over to 3 and down, we come a little bit lower than negative 2. But of course, as I just said, the whole graph is just a little bit low, and I think if I had gone through this point and this point a little more accurately, we would have come out pretty close to 3, negative 2. And of course, this is a hand-sketched graph. We don't expect laser-like precision, okay? Okay, so I say it should be 3, negative 2. Looks a little more like 3, negative 2.3. But of course, my line was a little low, so maybe this is a pretty good representative graph. Okay, well, this is an example of the equation of a straight line. Now you're aware that a straight line has equation y equals mx plus b, where m is the slope and b is the y-intercept. Well, if this is y equals mx plus b, m is 2, well that is the slope, isn't it? And b is negative 8. Well, the y-intercept's at negative 8, isn't it? Okay, so here we've confirmed the slope-intercept form of the line. And we've derived the equation of the line from a fundamental triangle.